The fossil record provides us with an incredible glimpse into our planet's deep past. Hidden in the ancient rock layers are the fossilized remains of extraordinary organisms that once called the Earth home, but are now consigned to the eternity of extinction. These prehistoric creatures may feel like alien beings in some ways, being so removed from us in time that it's hard to comprehend that they were real flesh and blood animals like us. But the fossil record sometimes provides us with another gift: evidence of prehistoric behaviours. One type of evidence for past behaviours can be found in the form of prehistoric injuries on fossils. These paleopathologies might be things such as bite marks, broken bones, or perhaps cases of diseases that the organisms suffered during their lives. Such discoveries are truly unique insights into the life and death of vanished animals, and I really think that seeing and understanding an injury on an extinct animal's skeleton is a very special way to relate to these creatures, to feel empathy for the suffering that the individual endured millions of years ago, and to assert that these organisms were just as real as the animals we love today. In this video, we'll explore 5 examples of some of the worst and most painful looking injuries preserved in the fossil record. These instances are all featured in a fantastic new book all about prehistoric behaviours, The Secret Lives of Dinosaurs. This book was written by acclaimed paleontologist and longtime friend of the channel, Dr. Dean Lomax, and is fully colour illustrated by Bob Nichols, truly one of the greatest paleo artists of this generation. The book details numerous cases of remarkable fossils that shed light on how prehistoric animals lived, fed, reproduced, and sometimes engaged in pretty bizarre behaviours, explaining the real science behind how paleontologists figured these things out in a brilliantly engaging way. I'll discuss The Secret Lives of Dinosaurs in more detail at the end, but if you enjoy the fossils featured in this video, I'm sure you'll love the book. Links to where you can buy it will be in the description below. To start us off, one of the most vivid instances of a severe and gruesome prehistoric injury is the case of the decapitated Tanystropheus. Tanystropheus is a particularly incredible kind of extinct reptile. These creatures lived during the Triassic period, with most of their fossils found in rocks on the Swiss-Italian border dating to 242 million years ago. They possessed extremely long necks with small heads at the ends. These necks are so long that they are almost 3 times the length of their bodies. Although they may resemble the famous long-necked plesiosaurs, they actually represent an example of convergent evolution, having independently evolved these extraordinary neck lengths. Instead of belonging to the plesiosaur lineage, they're classified as their own distinct family of Triassic reptiles, Tanystrophiidae. As Dr. Lomax discusses in Secret Lives of Dinosaurs, paleontologists have long debated Tanystropheus's precise lifestyle and habits, with some disagreement over how aquatic it truly was. But hey, paleontologists arguing over the aquatic nature of prehistoric reptiles, what's new there? Just ask Spinosaurus. Based on the anatomy of its teeth and the way they interlocked in a fish trap style, Tanystropheus was most likely a fish hunter. Additionally, some fossils preserve stomach contents from these reptiles, which include the remains of fish scales and hooklets from cephalopods. However, some researchers have questioned exactly how much time Tanystropheus would have spent in the water. It's understandable why these animals have caused so much controversy, as they are brilliantly weird-looking animals. The immense necks comprise 13 individual vertebrae and are reinforced by elongate ribs projecting from each bone, helping to keep the neck stiff. Older interpretations depicted Tanystropheus as terrestrial and quite lizard-like, but later research suggested that such a neck would have been a disadvantage on land, leading to the hypothesis that Tanystropheus was fully aquatic. Subsequent studies supported this fully aquatic idea, but in 2005, another paleontologist proposed that Tanystropheus was semi-aquatic, inhabiting shoreline environments and sometimes still walking on land. Since these reptiles lacked adaptations for continuous swimming, perhaps they spent a lot of time sitting in the shallows or on the shore and using their long necks like fishing rods, stretched out over the water, poised to snap up prey. These creatures could grow pretty large. The biggest known specimens likely reached between 5 and 6 meters in length, or over 16 to 20 feet, which would have allowed them to position their heads well over the water. Today, most paleontologists agree that Tanystropheus was semi-aquatic, spending time on shorelines and in shallow waters, but also occasionally swimming in slightly deeper nearshore areas to hunt. But looking at these slightly ridiculous animals with their super long necks, you might wonder, isn't that a vulnerable part of their bodies? There were plenty of predators around in the Triassic waters that could easily make a meal out of Tanystropheus. So did they ever target their necks? Well, yes, they did. In 2023, paleontologists described 2 specimens of Tanystropheus from Monte San Giorgio, the site in Switzerland near the Italian border where most fossils of these reptiles have been discovered. Both specimens consisted of skulls attached to partial necks, which were very well preserved but then abruptly terminated partway down. The larger individual belonged to the species Tanystropheus hydroides and preserved 10 vertebrae. The smaller one belonged to Tanystropheus longobardicus, a generally smaller species that coexisted with T. hydroides. In this specimen, 7 vertebrae are preserved, and then the neck abruptly stops. Looking closely at where the neck bones end, the researchers noticed that both specimens have distinct punctures that seem consistent with bite marks inflicted by other marine reptiles. These bites appear to have splintered the neck bones, indicating they were brutally violent impacts that completely severed the heads from the bodies of these poor ancient creatures. Some rather gruesome details of these attacks can be deduced from the directions of the puncture marks. The larger specimen was likely attacked from above and behind, indicated by a prominent gouge in the bone showing that the predator grasped the neck, then pulled back, biting the Tanystropheus at least twice in quick succession and severing the neck with its final deadly chomp. The smaller Tanystropheus was similarly attacked from above, with the predator presumably targeting the neck around the 5th vertebra, as punctures are visible on that bone. It then bit again around the 7th vertebra, ripping the neck apart. While the identity of the attackers cannot be determined with certainty, it is most probable that it was a large nothosaur, a relative of the plesiosaurs, or perhaps an ichthyosaur, another kind of marine reptile. The fact that we have 2 different decapitated Tanystropheus fossils suggests that this was probably not an uncommon way for these animals to meet their end. Clearly, the long necks were a functional weak spot in these semi-aquatic reptiles, and thus became a prime target for hungry predators. These injuries are truly a devastating testament to the ferocity of life in the Triassic seas. Next up, there are some more grisly fossilized injuries present in the skulls of some of the most famous and awesome predators in all of prehistory, the sabre-toothed cat Smilodon. These big cats, which it must be stressed are not tigers as they are so often called, were formidable hunters that inhabited both North and South America and existed from around 2.5 million years ago to just 10,000 years before the present. Of course, the most iconic parts of these felids' anatomy are those deadly looking canines, the sabres that inspired their name. Although the precise mechanics of how the cats employed these terrifying teeth is still a subject of some discussion among paleontologists, there's little doubt that they had the potential to be truly devastating weapons. In fact, direct evidence of their lethality was reported in 2019, when scientists documented 2 different skulls of the South American species Smilodon populator with some horrific injuries to their heads. As discussed in the Secret Lives of Dinosaurs, these skulls were discovered in 2 different provinces in Argentina, and both have rather suspicious holes on the top surfaces. Both these holes are roughly elliptical in shape and are located towards the front of the skulls, between where the eyes would have been. When these openings are matched up with the saber teeth of other Smilodon, they correlate almost perfectly to the shape and size of these canines. So, seems pretty clear what was going on here. Lethal battles between Smilodon populator individuals, which in at least some cases ended extremely badly for one of the combatants. Now, the authors of this 2019 paper do note that they can't completely rule out the possibility that these punctures were inflicted by a different species, perhaps from some kind of particularly feisty prey animal that kicked the heads of the saber-tooths. However, the size, shape, and general features of the injuries do point to the most likely culprits being other Smilodon. Amazingly, one of the skulls, the one unearthed in Buenos Aires province, actually shows signs of bone regrowth occurring around the margins of the puncture wound. This means that despite how severe this massive hole in the skull looks, this individual managed to survive the attack and would have lived for quite some time afterwards. I guess this cat still had 8 lives left. The other Smilodon, however, was not quite so lucky. This skull shows no signs of healing around the puncture mark, so that was the killing blow for this individual. The deadly sabre of its aggressor must have gone so far into its head that it pierced the brain. Many living cats will fight one another for resources such as territory, food, mating rights, or to assert dominance, and so it's likely that the iconic sabre-toothed cats engaged in similar behaviours. Some comparable injuries in modern cats, where teeth pierce the skull, have also been documented, so this again seems to support the idea that these Smilodon injuries were inflicted during combat with other Smilodon. These fossils paint a truly vivid picture of the brutality of some prehistoric animals, as these mighty beasts battled to the death, utilising their sabres as vicious killing tools that not even other members of their own species were safe from. Since we've already looked at amputated necks and heads in those unfortunate Tanystropheus fossils, let's now examine the opposite end of the body with the case of an amputated dinosaur tail. In 2013, paleontologists reported their discovery of a rather incredible fossil. This specimen was a partial skeleton unearthed in South Africa from rocks dating to the early Jurassic, and belongs to a kind of dinosaur called Massospondylus. Massospondylus is an example of an early sauropodomorph, the great lineage of dinosaurs that includes the true sauropods, which would eventually give rise to the largest land animals to ever walk the planet. This Massospondylus individual was not as titanic as its much later relatives, but was still pretty sizable, probably reaching about 6 meters in total length, or nearly 20 feet, with a long neck and long tail. This particular partial Massospondylus skeleton, though, preserved something rather unexpected. A total of 25 vertebrae are present in this fossil, comprising much of the back of this animal and some of the tail. However, the final 3 vertebrae in this sequence are all fused together, with lots of extra bony growth that joins these separate bones into one big triangular block. The rest of the tail vertebrae are preserved nice and completely, but these final 3 have clearly been severely damaged, and no more tail bones are found after these ones. The tail must have been amputated. Incredibly though, despite being violently detached, this Massospondylus clearly survived the traumatic event, as the extensive bony overgrowths are a sure sign that it continued to heal. Comparing this specimen to more complete fossils of Massospondylus, paleontologists deduced that this individual was missing about half of its tail vertebrae, so whatever caused it to lose its tail, it took off a shockingly significant part of this dinosaur's anatomy. This poor sauropodomorph was a true survivor though. Such a devastating injury to the tail of a reptile is not without precedent. We know that modern crocodilians are capable of surviving some awful amputations, with surveys of Nile crocodile populations revealing that around 16% of them suffered some form of tail injury, often involving the loss of much of the appendage. It's thanks to the strong immune systems of these reptiles that they can sustain such damage and continue living, though not without some hindrance. American alligators have also been shown to be capable of partially regrowing amputated tails too, although not to the same extent that some lizards and amphibians can regrow lost tails. It's unclear exactly how this Massospondylus lost its tail, but it could have been torn off by a large predatory dinosaur. The prime suspect in this case would be the awesomely named Dracovenator regenti, the largest predatory dinosaur known from the geological formation in which this specimen was found. And this is the scenario beautifully illustrated by Bob Nichols in Secret Lives of Dinosaurs. That must have been a terrifying event to witness. A large, potentially 6.5 meter long carnivorous dinosaur tearing off half the tail of this poor Massospondylus. Yet the sauropodomorph clearly escaped and continued to survive for at least a little while longer. The early Jurassic world must have been a chilling place to live sometimes. As if to further illustrate the brutality of the early Jurassic planet, our next specimen also dates from this period of time. This is a record-breaking fossil of the dinosaur species Dilophosaurus weatherilli, a predatory theropod dinosaur made famous for its role in Jurassic Park. However, the Dilophosaurus of reality was a very different animal from its portrayal in the film. Instead of being a little guy with a terrifying extendable neck frill and the capability of spitting venom, the real dinosaur lacked a frill and venom, but was significantly larger in stature, measuring some 5 to 7 meters in total length, or about 16.4 to 23 feet. The real Dilophosaurus was the apex predator of its early Jurassic ecosystem. It's known from fossils uncovered in Arizona, and must have been a rather spectacular animal to see in the flesh, possessing those large, paired head crests. So why is this particular Dilophosaurus record-breaking? Well, when paleontologists studied it in 2016, they counted an astonishing 8 different bones in the forelimb and pectoral girdle with injuries on them. Before this, the maximum number of forelimb or pectoral girdle bones with injuries on them was 4, a specimen of T-Rex in fact. But this battered old Dilophosaurus has it beat. Interestingly, the specimen we're talking about here is the holotype of Dilophosaurus, the original specimen on which the definition of Dilophosaurus weatheralli as a species was based, and which was first unearthed back in 1942. This poor animal had a fractured scapula and radius on its left side, as well as abnormal bony growths, kinds of fibrous abscesses on the left ulna and one of its finger bones. On the right side, this animal's humerus was twisted in a very unnatural way, its radius had bony tumours on it, and 2 of the third finger bones were deformed as well. However, all these pathologies show evidence of extra bone growth, indicating that this tough old Dilophosaurus went on living for months or possibly years after it first sustained this damage. Clearly though, this theropod would have been impaired in some of its day-to-day activities. In fact, the third finger on its right hand was so extensively damaged that it would no longer have been capable of the full range of motion this digit should have had, as its flexion was significantly reduced. This undoubtedly would have made it much more difficult for the predator to grasp its prey with its hands, and so ultimately, all these injuries likely contributed to this dinosaur's eventual death. The twisted humerus in the right arm may have resulted from this Dilophosaurus experiencing so much pain in its left arm and hand, leading it to rely much more on the right arm to avoid the pain of using its left. Such behaviour and development of pathologies in this way is seen in living birds. It's a tragic story of a terribly brutalised Dilophosaurus, but it also demonstrates what incredible survivors dinosaurs were. These predatory theropods lived violent lives, tackling large prey that fought hard to escape and avoid being eaten, and it's easy to imagine that encounters like this could have caused the pathologies seen. The early Jurassic truly was a brutal world. Speaking of Jurassic worlds, our final instance of some of the worst injuries preserved in fossils concerns one of the stars of the 2015 film, the Mosasaurs. Once again, the Hollywood versions of these animals are rather different from their real-life counterparts. In this case, the Jurassic World Mosasaur was vastly oversized compared to the real thing. In reality, the largest estimates for the biggest specimens of Mosasaurus put it at between about 15 to 17 meters, about 49 to 56 feet. Still pretty enormous predatory marine reptiles then, just not kaiju-sized like in the films. Mosasaurs as a lineage existed during the final 30 million years or so of the Cretaceous period, coming to dominate the ancient waterways of our planet after the pliosaurs and ichthyosaurs went extinct. Mosasaurs are members of the Squamata, meaning they are closely related to lizards and snakes. A remarkable fact, meaning these prehistoric ocean goers were literally massive marine lizards. Mosasaurs were undoubtedly formidable predators of sharks, turtles, and other reptiles, and we have a lot of evidence suggesting they would sometimes turn violent towards one another as well. One of the most striking cases of a clash between mosasaurs was discovered when an approximately 85 million year old skull of Tylosaurus was unearthed in Kansas. This sizable reptile would have been among the top predators of the Western Interior Seaway, which divided North America into two and submerged Kansas at this time. This particular specimen, however, was littered with bite marks across the top of the skull, near the eye socket, and all over the right lower jaw. None of these injuries showed any signs of extra bony growth either, so whatever attacked this mosasaur delivered a killing blow. The neck vertebrae were also discovered at a rather unnatural angle compared to the skull, suggesting its neck was snapped during this attack. The only other thing in those oceans of Kansas that could have posed such a threat to Tylosaurus would have been another mosasaur. And so it seems that this fossil represents a case of this approximately 5 meter long individual meeting its end at the jaws of an even larger, potentially 7 meter long Tylosaurus, going by the size of the bite marks. This aggressor must have approached from slightly below the left side of the victim, impacting the head and causing it to roll to the right, so that the attacker's lower teeth could puncture the right lower jaw, while the upper teeth gouged into the top of the skull as the rolling motion occurred. Several bones of the skull were crushed and detached during this bite, and the spinal cord was probably severed at the base of the skull immediately. So this was at least a very quick death for the reptile. Other instances of mosasaurs attacking one another are known, and are also featured in Dr. Lomax's new book, such as cases where teeth were recovered from between neck vertebrae, and a particularly remarkable specimen of Mosasaurus missouriensis discovered in southern Alberta that preserves several lesions on the lower jaw, as well as an embedded tooth from another Mosasaurus. This large 6.5 meter long individual survived this attack though, as there are signs of bone healing, meaning it continued swimming along even with a tooth lodged in its face. Clearly, the mosasaurs were not to be messed with, even if you were a mosasaur yourself. These large marine reptiles would often go after each other as potential food sources, and engage in some horrifically violent fights to the death. The fossilized evidence of these awful injuries reveals that these big sea lizards could be truly menacing animals. So there are just a few of the most insane injuries that have been preserved in fossils. Paleopathologies are a brilliant way to gain insight into prehistoric behaviours. Every single animal in existence will perform innumerable behaviours throughout its lifetime. The behaviours of creatures alive today are incredibly rich, complex, and fascinating to learn about. But although ancient bones may seem like pretty stationary objects, certain specimens reveal the secret lives of these long-lost beings, helping to paint a picture of a vibrant, life-filled world that existed long before our time. And that's exactly what The Secret Lives of Dinosaurs is all about. This fantastic new book, which includes all these fossils I've talked about in the video, plus loads more, explores numerous different aspects of behaviour in the fossil record, from how dinosaurs and other prehistoric animals reproduced, how they fought and consumed each other, how some of them survived against all odds, and how they tragically perished. The text is so engagingly written by paleontologist Dr. Dean Lomax, the author of Locked in Time, which I've previously made a video about on the channel. He takes you on a fascinating tour through deep time, exploring some truly mind-blowing fossils and explaining the science behind them in a wonderfully accessible way. Every fossil is stunningly illustrated in full colour by paleoartist Bob Nichols, bringing these ancient organisms to life and depicting the behaviours preserved in the fossils in his incredible art style. I seriously cannot recommend this book enough. It's perfect for any lover of prehistoric life, and there are many specimens featured in the book that I'd not even heard of before, so I feel like I've learned a lot reading it. Links to where you can purchase the book will be in the description below, and if you've read the book then be sure to leave a review of it. Thanks so much for watching this video, I really hope you enjoyed it and learned something new. Please do like this video and subscribe to the channel if you enjoyed it, and be sure to press that bell icon so you don't miss our next upload, and so you can learn more about our world, its history, and the wonderful life that surrounds us all.